Good evening, students. Yesterday I have solved some questions related to your grouping of resistances. Today let me tell you some of the tricks to solve this kind of grouping of resistances. See, in your questions, at once if you see the question, it will be, if you practice some of the questions, then there are some questions it will be easy to know which of the resistances they are connected in series and which of the resistances are connected in parallel. But there are some circuits or networks you will find too difficult. What are the resistances they are connected in series and what are the resistances they are connected in parallel. So there are some tricks to know to solve that kind of electrical networks, to solve the solve for the entire resistance of the circuit. So first method is, let's say there is a condition, Wheatstone Bridge condition. Wheatstone Bridge. Wheatstone Bridge, it's already discussed in your capacitance chapter. Wheatstone Bridge condition is what? Suppose there is a network like this, network of resistors like this. We will see what is the meaning of a Wheatstone bridge and what is its purpose in later classes. But before that, you must know how to solve the questions. Already we have solved this in your capacitance chapter. Suppose there are 5 resistances like this, they are connected in a circuit. Let's say the resistance here it is R1, here it is R2, this is R3 and R4, and let's say this is R5. You are asked to calculate the resistance between the terminals AB. But in this case, it is very difficult to identify what are the resistances here. They are connected in series, who are the resistors connected in series and who are in parallel. In this case, you check first condition. The condition is, you check if R1 by R2, the value of R1 by R2 is equal to R3 by R4, or see, take the R3 here, R1 by R3, if it would be R2 by R4, then this condition is called your Wheatstone Bridge, balanced Wheatstone Bridge condition. If this is the situation, this two scenario, then you do one thing, remove this resistance R5 from the network. But we will see why we are removing here. This is called your balanced Wheatstone Bridge condition. So if 4 resistances are given in this like R1, R2, R3, R4 and R5, then you just simply remove R5. This is called your Wheatstone Bridge condition. Wheatstone Bridge, this is the condition of Wheatstone Bridge, and the corresponding diagram will be like this. Means that R5 will be ineffective. Now easily you can understand that if a current will come here, it has 2 outlets. If I1 amount of current will pass through this, I2 amount of current will pass through this, then I is equal to I1 plus I2. This I1 will pass through this, means this 2 they are in series, this 2 they are in series, and this branch they are in parallel. Means you need to find out the effective resistance R1, R2 in series, R3, R4 in series, and both the branches are in parallel. So it is easy to understand by using your Wheatstone Bridge first, but provided this condition should be satisfied. Now sometimes you will encounter a problem where some of these circuits you won't find, the circuit will be like this, but you won't find that condition is satisfied. So in that case, there are different processes, like you can apply Kirchhoff's rule, that I am going to tell you later, how to apply Kirchhoff's rule and what are the rules, then you can apply that. But there is other techniques, like there is a technique called star delta method or delta star method to solve that kind of circuit. What is that? So your second technique is delta star or star delta star method. What is that method? This method will be applicable. You see, suppose there is a circuit like this. Exactly in the manner what I have done previously. These are the resistances. Between A and B, you need to find out the effective resistances. In this case, you check 5 by 10 is 1 by 2, but it is 10 by 5, it is 2, so it is not a balanced Wheatstone bridge. So that condition, that formula means omitting that 5 ohm cannot be applicable in this case. So in that case, we are going to apply delta star method. So let us understand what is delta star method. Delta means what? A delta mesh corresponds to a mesh like this. In the form of delta, if three resistances are connected here like this, suppose this is your resistance R1, this is R2 and this is R3. They are connected in this manner in terms of your delta. Then this delta combination can be replaced by a star combination like this. Star combination like this. See, we can have the star combination. Suppose this is the point A, this point is B, this point is C. Now your star combination will be like this. Means this point is your C, this point is your A, and this point is your B. Now, what are the value of these three resistances? Means this delta method can be replaced by the star which is inside, means this method, this one. So this resistance, you see, this resistance it is connected at the joint of R1 and R2. So let us mark this resistance to be R12, the resistance value of this one, R12. You observe the point C. At point C, R2 and R3, they are joined together. That's why this resistance, you mark it to be R23, and this resistance you take, they are connected to the point B, and the two resistances are R13. So mark that resistance to be R13. Now let us find out the value of R12. What are the values of 1, 2, 1, 3 and 2, 3? Just you remember. R12 is what? You see the three resistances R1, R2, R3. R12 is what? It is the product of R1, R2 by R1 plus R2 plus R3. Secondly here, similarly, R23, it would be R2 into R3 divided by R1 plus R2 plus R3. Similarly, R13 would be R1 into R3 divided by R1 plus R2 plus R3. So once you replace this three resistances connected in a delta shape to a star shape, these are the resistances what you are going to replace. Basing on this star delta method, we can solve this circuit. This can be solved by applying your Kirchhoff's rule also. You got? Now we can solve this by the method of star delta method. See, three resistances, it is a delta, this is another delta. So you can take in either side. either this side it convert it to your star, or this side you convert it to a star. So let us take the left side. So in this case, so you can redraw the diagram. Let's say this point is A and this point is B. Let's say this is C and this is D. So now I can replace, I can redraw the diagram, see. Like here, in this case, and in this case. This will be the delta, replacement of your delta in terms of star. Got? Means, if you draw the diagram, your point A is here. From that you took one diagram to one resistor here, another resistance here, and another resistor here. That case, you see another resistor here and another resistor here. This end is your B, this end is your A, this point is corresponds to this point is your C, this point is your D. Now these two resistances, one is 10, another one is 5. If it is 10, it is 5, then this resistance would be how much? 10 into 5. This resistance would be 10 into 5 divided by, you see all the three resistances, 10 plus 5 means 10 plus 10, 20. So which is 10 into 5, 50 by 20. 50 by 20, which is 5 by 2. 5 by 2. So this resistance will be 5 by 2. 5 by 2. Now comes to this resistance. This resistance you can take this 2 because they are joined at point C. So your value is this formula, 5 into 5 by 10 plus 5 plus 5. This formula. Or you can take, suppose you can name 1, 2, 3, in that way you can apply this formula. So ideally you take this to be R1, this to be R2, and this to be R3. So you can apply that formula. So this resistance I am writing it R12, this resistance would be R13, and this resistance would be R23. Now that formula you can apply easily. Now R13. R13 is 5 into 5 by 20. So 5 into 5 is how much? 25 by 20 ohm. Now this would be how much? This one will be 10 into 5 by 10 plus 5 plus 5, 20. Means it will be again 5 by 2 ohm. You apply this formula, then you are going to calculate. These are the resistances. But now it is simple, it is clearly visible in the diagram. If a current will come here, the current what is entering to the network I, the entire current will pass through this 5 by 2 ohm network resistance. It will come here, it gets splitted here into two ways. Suppose in this branch I1 amount of current will flow, and in this branch I2 amount of current will flow, and I1 amount of current will reach here through this resistance is 10 ohm and this resistance is your 5 ohm. Means these two they are in series and these two they are in series, and this branch and this branch they are parallel. So your effective value, let me clearly write here, this is 10 and this is 25 by 20. So they are in series, so their series resistances will be how much? 25 by 20 plus 10, so which is equal to 25, LCM you take 20, so this is 25 plus 200, it means 225 by 20, divide it with 5, 4, 20, so it will be 45 divided by 4. Means the series resistance of these two resistors will be 45 by 4, And again similarly you can find the effective resistance of these two. They are in series. 5 by 2 plus 5. 5 by 2 plus 5. So which is 15 by 2. 15 by 2 ohm. Now I can read out the diagram. The diagram would be like this. This is 5 by 2. 5 by 2 ohm. And that resistance is, you can take here like this, another resistance like this, and they are again rejoined to the point B. This is point A, and this resistance is 45 by 4 ohm, and this resistance is 15 by 2 ohm. Now these two, they are in parallel, so we can find the resistance in parallel. The formula, since two resistances are there, the formula is Rp is equal to R1 R2 by R1 plus R2, the general formula. Now R1 into R2 is how much? 45 by 4 into 15 by 2 divided by 45 by 4 plus 15 by 2. Now you can multiply and solve it. You take, so just write 45 into 15 by 4 into 2, 8 divided by, take LCM, which is 4, so which is 45 plus 30. Now I can solve it here, so keep it like in that way. 45 into 15 by 8 into 4 divided by 45 plus 35 plus 30, which is 75. 4 2s, again it will be 4 2s are 8. Now 15, 5, 5, 9. So your final answer is 9 by 2 ohm. So this part, they are connected parallel, and you can replace this by a single resistance like this, and whose resistance will be 9 by 2 ohm. Now you see these two resistance, they are in series. 5 by 2 means 2.5 ohm, 9 by 2 means 4.5 ohm. If you add, so your effective resistance will be in series R1 plus R2, 4.5 plus 2.5, which is 7 ohm. So between A and B, the value of your effective resistance will be 7 ohm. This is the second method. Thank you. Suppose you have a network of resistances like this, and you are asked to calculate the effective resistances between this end A and B. All the resistors, they have your same resistances. In this diagram, all of you just see all the resistances, they are identical. Let's say it is R or 1 ohm, let's say, or 2, whatever the value, but you see all the resistances are identical, means equal value. If you see here, there are 3 deltas, and the situation is having symmetry. Symmetry means what? Suppose if you remove this resistance, you will find there are 2 deltas. Means this delta is identical with the second delta. The first delta is identical with the second delta, and there is a middle delta. Got? So the symmetry here means there is one delta, there is another delta if you take a point here. Got? So if you draw a line over here, this is called line of symmetry. About this line, this side and this side, they are identical or mirror image of each other. This is the symmetry in this situation. So if this kind of situation is there, all the time you try to replace this middle delta to your star like this. So you can replace like this. This is the junction point. Got? All are equal resistances. So if you mark, it will be 1 1 1 1 1, all the resistances 1 ohm. So this would be how much? 1 into 1 by 1 plus 1 plus 1 means 1 by 3. So this resistance will be 1 by 3. This will be also 1 by 3. This will be also 1 by 3. Now you just replace the diagram in this way. You just remove this 3 part. This one, and this one. Now your diagram will be like this. Clear? So this is 1 ohm, this is 1 ohm, this is 1 ohm, this is 1. Now it is clear from the diagram, you see, this 1 and this 1 by 3, they are in series, because if a current will come here, it is distributed in this and this branch, I1, I2, let's say. This I1 will flow through this 1 by 3 ohm resistances. It means these two, they are in series. Also, whatever be the current comes in this branch, the same current will pass through this. Means these two branches, they are in series, these two are in series. So I can replace this diagram, it will be like this. Means 1 and 1 by 3, they are in series. So the effective resistance will be 1 plus 1 by 3, because in series the formula is R1 plus R2. So which is 4 by 3. Means this resistance will be 4 by 3. This two resistance will be 4 by 3. So your network will become, point will be B, means this diagram will be, the point is A here. You take to be 1. Here it is 1. This would be 4 by 3. This is also 4 by 3, and this is 1 and this is 1. The middle diagram would be 1 by 3. Got it? Now, in this diagram you see, in this diagram, this end is A and this end is B. This 4 by 3 and this 4 by 3 means they are forming a bridge over here, Wheatstone bridge. Let us apply the Wheatstone bridge condition. If satisfied, no, then it can be solved. Like 4 by 3 by 4 by 3, it is 1. 1 by 1, it is again 1. It means this resistance is acted like a bridge here, but the bridge is balanced, so this resistance has no role in this case. So you can remove it from the circuit. Now your resistances will be, you see again, this 4 by 3, this 4 by 3, they are connected in one branch, so they are in series. This 1 and 1, they are in series, and these two branches, they are in parallel. So your answer will be 4 by 3 plus 4 by 3 means 8 by 3, and 1 plus 1, this would be 2. So this 8 by 3 and 2, they are in parallel. So your final value of your resistance would be 8 by 3 into 2 by 8 by 3 plus 2. See, this branch, the effective resistance is 8 by 3. This branch, the effective resistance is 2. So this 8 by 3 and 2, they are in parallel. I have applied the formula for parallel combination. So which is 16 by 3 divided by 14 by 3, which is equal to 16 by 3 into 3 by 14. 3 got cancelled. So your answer is, if you 8 by 7 ohm. Now students, the same question can be solved by two other different methods. What are the methods? Already I have told you, in this situation, this circuit has some symmetry. Symmetry in the sense, you see, this delta and this delta, they are identical. Means, if this 1 ohm would not have been there, so the symmetry point is here. Means, if you draw a line at this point, then this delta and this delta, they are the mirror image of each other. So the symmetry, and this is your line of symmetry. But because of this 1 ohm, the symmetry is not there. So my point is, if you divide this 1 ohm to 2 equal half, like this, means half ohm this side and half ohm this side, means left side of this line and right side of this line, they represent two different group of resistances of a network. Means this and the left side portion and the right side portion, they are the mirror image of each other now in this case. So this is 1 ohm, this is 1 ohm, this is 1 ohm. Now you see this point and this point, they must have at the same potential. These 2 points, they must have the same potential. Now you can join these two. If there is a situation like this, draw a line of symmetry, and whatever be the points there, you just tap here. Tap this point to this point. So your diagram would be like this. Means half of the resistance, this point will be, if you tap it here, means this single resistance will act as 2 different resistors. One is your 1 by 2, another one is R by 1 by 2. Now your diagram would be like this. You take one resistance here, and the resistance would be like this in this case. This would be half and this would be half. So the previous diagram can be redrawn in this way if you find the symmetry in your network. Now this branch and this branch, the 2 branches, they have equal resistances, and this branch and this branch, they are in series. So the total resistance will be suppose as equal. This branch is having resistance R, this branch is having resistance R, so total resistance will be R plus R to R. Now let us find out R. R means resistance of this part. Now this 1 and half, all of you just see, this 1 ohm and this half ohm, they are in parallel. So their effective resistance would be how much? Means this 1 and this half, you can have 1 into 1 by 2 by 1 plus 1 by 2. Formula for parallel means R1 R2 by R1 plus R2. So which is half divided by 3 by 2. So which is your 1 by 3 ohm. So you can replace this 2 by your 1 by 3. So now I can replace this. Redraw this diagram, and can have one single resistance in here instead of that 2, and those resistance is 1 by 3 ohm. Now you check if a current is coming here, it is distributed in 2 branches. Whatever current will flow through this 1 ohm resistance, the same current will flow through this 1 by 3 ohm resistance. It means this 1 ohm and this 1 by 3 ohm, they are in series. So the effective resistance in series circuit would be R1 plus R2 formula. So means the effective resistance of these 2 resistors will be 1 plus 1 by 3. So 1 plus 1 by 3, which is 4 by 3. It means we can replace this 2 by a single resistance. In this case, the resistance will be 4 by 3 ohm. Now you see, this 1 ohm and this 4 by 3 ohm, they are in parallel according to our formula. According to our process, they are connected in parallel because the one end of these 2 resistors are connected here. The other end of the same 2 resistances are connected at some other point. Yes, they have a two common points. So they are connected in parallel. Now the effective resistance of this part would be, we can apply this formula R1 R2 by R1 plus R2. So which is 4 by 3 into 1 by 4 by 3 plus 1. So which is 4 by 3 divided by 7 by 3, and which is how much? 4 by 7. So you got your R. R is equal to 4 by 7. But the entire network's resistance would be 2R, which is 2 into 4 by 7. So R effective is equal to 8 by 7 ohm. So this is another process. So there is another technique. Another technique is what? Like junction removal method. There is a process. It's called junction removal method. Let me redraw the diagram again, and just I will tell you, you will apply that method. The diagram will be like this. Again that same diagram. You will try it. Junction removal is applicable if there is a symmetry in the diagram. If there is a symmetry in your circuit, then that junction removal method can be applicable. Suppose I amount of current is coming to the junction. Let's say I1 amount of current will flow through this. So it means in this branch if you can say, let's say I2 amount of current is flowing through this. This I2 amount of current will come to this point, and let's say some I3 amount of current will flow through this branch. This I3 current will come here. This I1 current will come here, and in this branch, see, to this point I2 amount of current is coming. Through this branch I3 amount of current is going. It means through this branch only, whatever be the left out of amount of current, which is I2 minus I3, this amount of current will come here. And to this point, this I1 amount of current will flow. I2 minus I3 current will come to this point, and there are two, again there is a two symmetric distribution of current here. You see, this end is connected to a 1 ohm resistance and this ohm is connected to a 1 ohm resistance. It means, if we can consider like this I2 minus I3 amount of current will pass through this I2 minus I3. Now you see, in this way I2 minus I3 is coming to this point and it is again going through this branch. It means this point, at this point there is no interference of the current at this point. Means here the current is I1, to this one it is I2 minus I3, and through this branch I3 and this 2 means I2 amount of current is coming. You see the current distribution. The way they have started here, in the same manner they are just living at the other end of the junction. So this is the symmetry here. This is the current distribution symmetry. If this will be the situation, you see, if you remove this point from the junction, if you remove this branch from the junction, there will be no alteration in the current flow in the circuit. If you disconnect it, there will be no alteration in the current flow. Now you can have your diagram. It means what? The current flowing through this branch and this branch, they are same. Means this is a 1 ohm resistance, this is 1 ohm resistance. If the current flowing through them are same, means they are in series. So the effective resistance of this two will be, see, remember all the resistances are 1 ohm. So this two, they are in series. Because of that reason, their effective resistance would be 1 plus 1, your 2 ohm. So I can replace this junction by a 2 ohm resistances across this end. So it is 2 ohm and this is 1 ohm. Now in the diagram it is clear. This 1 and 2, they are parallel. So I can replace that right here. Look at parallel formula. Rp is equal to R1 R2 by R1 plus R2. So which is 1 into 2 by 1 plus 2. So which is 2 by 3. Means these two resistance I can replace by a single resistance. But resistance will be 2 by 3 ohm. Now it is clear. This 1 ohm resistance, this 2 by 3 resistance and this 1 ohm resistance, they are in series. As, see, if a current flowing through this is I1, the current flowing through this branch is I2, the same current flows through these three resistances. So if they are in series, so their effective resistance will be the sum of all the three resistors. So which is 1 plus 1, 2 plus 2 by 3. So 2 plus 2 by 3 is the effective resistance of this branch. So 2 plus 2 by 3 is how much? 3 into 2, 6 plus 2, 8 by 3 ohm. So means I can replace this branch with a single resistance of 8 by 3 ohm resistance. Similarly, this two, they are in series, and you can replace this two resistor by a single resistor. This is 1 ohm and this is 1 ohm, so their effective will be 2 ohm. So I can replace this by a 2 ohm resistance. Now all of you just see these two resistors, they are in parallel, so their effective resistance would be, so the final R effective is equal to that formula R1 R2 by R1 plus R2, so which is 8 by 3 into 2 by 8 by 3 plus 2, so which is 16 by 3 divided by 14 by 3, so which means 16 by 14.